everyone, welcome back to my channel. Suhail this side. So this would be the seventh video in the Kafka Zero to Hero series, right? So in the last videos we have already discussed the partition in detail, and also we have discussed how we can scale Kafka by introducing more partitions or more consumers, right? And we also see how we can ensure the messages should process in order while we are scaling Kafka. So we have seen different trade-offs, and we have discussed different scaling scenarios, how we can increase, how we can scale the Kafka, right? And now today's agenda would be, we will actually going more deep dive what Kafka does behind the scenes when consumer consumes the messages, right? So we'll go more deep dive into the things right now. Now there should be some way that how we can know that how many messages are being produced by the producer. There should be some way of knowing how many messages are consumed by the consumer, right? Similarly, we should be able to know how many messages are lagging, and in the end we'll discuss about different scenarios, and we'll see in which scenario the lag, how the consumer lag behaves in different scenarios. So we'll discuss all this in detail. Now without wasting time, let's get started. So just look at the image here, right? So we have a producer, we have a consumer, right? And we have a topic. So we have already discussed, for we have a partitions of a topic, right? So imagine this is a partition 0 of this particular topic, and where the partition and topic lies on the Kafka broker, and producer on the other end and the consumer on the other end, right? Now what actually Kafka does behind the scenes when consumer consume the message. So first of all, we need to understand, okay, now consumers in Kafka works on pull based approach, right? So as and when we produce the messages to the Kafka broker doesn't go and notify each and every consumer, okay, consumer, this is the message for you, okay, the second consumer, this is the message for you. Kafka doesn't work this way. So how Kafka works actually, the consumers in the Kafka actually polls at a periodic interval, right? Consumer polls the Kafka broker and actually gets the messages, gets the number of messages from the Kafka broker, right? So this is how actually the consumers in Kafka works, right? Now when consumer consumes the messages, it has to notify Kafka broker that it has consumed or processed the message, so that Kafka can increase the offset for that particular topic partition, right? So it has to, there should be some way, right, of notifying to the Kafka broker that to increase the offset for that particular partition, right? Now there are two ways of that, right? So first way is, consumer can manually notifies the Kafka to commit the record, and then only the Kafka can increase the offset. So this is approach number one. Now the second approach could be, as soon as consumer consumes the messages, right? Now Kafka broker also knows that how many messages it has sent to the consumer. For example, the consumer requested 10 messages and Kafka broker gives the 10 messages to the consumer, right? Now Kafka broker knows that these many messages are being sent to this consumer. So Kafka broker can also internally increase the offset based on this information, right? So this could be the other way. Now by default, how actually things works, so there is a configuration for this. So there's a configuration for this. The by default configuration is enable auto commit is the property. So by default this property is true. So what it means, when this property is true, it means as soon as consumer consumes the message, so Kafka broker knows how many messages are being sent to this consumer. So based on this information, Kafka automatically commits the records and increase the offset based on this information, right? And if we false this property, if we make this property false, then it would be a responsibility for consumer to notify or to commit the records manually into the Kafka broker, so that after then only the Kafka broker can increase the offset. So this is the second approach, right? So whichever approach we'll choose depends on our use case, but Kafka has to maintain this offset information somewhere on disk, right? So whatever approach you choose based on your application load or whatever the use case, right? But Kafka has to maintain this offset information somewhere on disk, right? Somewhere on disk it has to maintain this information. Okay, now this consumer has consumed these many messages. Now this is the latest offset for this consumer, right? So that whenever you restart the Kafka cluster or any new consumer joins or leaves, it has to know till which offset the messages are already processed by the consumer, so that it can give the new messages only to the consumer. It won't give the old messages, right? So it has to maintain some kind of information onto the disk, right? Now this is where actually the consumer offsets topic would come in picture, right? So when in the episode second and the episode third, right, in the previous videos also we have seen the consumer offsets while doing the Kafka, while creating the Kafka topic, when while I was traversing to the directory structure, right, in the data directory where actually Kafka stores the data, right? There we have seen there was internal topic, the consumer offsets. Now today is the day where we will discuss, okay, what this topic actually holds and why this topic is very 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 important for maintaining the consumer offsets and also for scaling Kafka, right? So this topic is very very important, and this is where this topic would come in picture. Okay, now I would ask you simple thing, right? So if I have to design this by ourselves, how would we do this? So think very simple approaches. Now let's assume the problem statement is we are given a topic, right? So we are given a topic, this is the topic, right? And we are also given a partition, right? We are given a topic, we are given a partition, and we are given a offset, right? Now there are multiple consumers who are consuming continuously, but we have to design the functionality that which consumer has, which consumer group actually has already consumed how many messages, right? So that next time when consumer asks for more messages, we should give the new message, right? So how we can think before looking or before going deep dive, I would like to I would like each of you to think this problem and come up with a simple approach so that you can think of it how easy it is, and Kafka would does this same way, right? So think of it like a simple problem and let's come up with the solution, then we'll go into deep dive, right? Now we'll try to solve this problem by ourselves and then we'll discuss how actually Kafka has done this, right? Now let's solve this problem, right? Now how we can solve this, what we have actually we have is we have the consumer group, we have the offset, we have the partition. These are the three things we already have, right? Now how we can store this information, what we need to store, we need to just maintain the information which consumer group has consumed how many messages. This is the simple information we need to maintain, and for which topic partition, right? So this is the simple information we need to maintain. So what we can do is we can use simple dictionary, the map kind of structure to hold this information. For example, the map could be the key value pair, we already know. The key could be the offset key, right? So this would be the key and the value could be the offset value, right? So the offset value could be the offset and the timestamp, right? The offset is, for example, when the consumer asks for messages, so okay, the Kafka would check, okay, what is the current offset from this value. So based on that, it would try to give the new messages based on this value, right? Now let's see the flow again. If we have the key and value, what would be the key? Key would be the group name, the topic and the partition, because this is what we have actually, right? And for this combination only we need to maintain the information which consumer group has consumed how many messages, right? So we only have this much information, right? So we have designed the simple, the key value pair, the key is the offset key, value is the offset value. Now let's see the flow by introducing this key value pair. Now assume for simplicity the properties enable auto commit property is true. So whatever the way is, it is just for simplicity, just assume this is the property and this property is true. Now let's see the flow. So consumer, how the flow would be, the consumer would request for 10 messages, right? So consumer would request for 10 messages. What information would consumer send? when it will ask for 10 messages. As we already seen, we also do the demo for this, right? So consumer, when we have to consume the messages from a topic, we have to mention the group. So which group we are belonging to, which group this consumer belonging to, and we have to also mention the topic, right? So topic, from which topic we want to get the data, right? Now Kafka broker already has the metadata in memory. For example, which partition is assigned to which consumer. This we have already discussed in episode 2, where we have discussed the controller and the broker responsibility, right? So controller responsibility is to assign the partitions to the particular broker, right? So Kafka broker already has all this metadata information in memory, right? Now Kafka broker can easily build the offset key. How? The group name is being passed into the command, right? When the consumer is requesting for 10 messages, the topic also there, but partition it has to get, right? So how the partition it has to get? It already has the metadata in memory, right? Now what would be the next step? So consumer has requested 10 messages, Kafka gives the 10 messages to the consumer. Simple, right? Now how Kafka can increase the offset? It can simply go to this dictionary and can just update the offset value, right? Offset value, and it can just update the offset plus is equal to 10, and the last timestamp is now. This is the simple value, right? So this is how actually we as an engineer we thought, okay, this is the simplistic approach we can design to maintain this information, right? So this is the very simple strategy or approach we have designed. Now let's see the demo, how Kafka actually does this. Let's see the demo, right? So I'll just okay, I'm just doing the Docker Compose app. We are just starting the Kafka cluster, right? So the same way I have already checked in all the things. Just do the Docker Compose up, and our Kafka cluster would be up and running in some time. So it is coming up. So yeah, it is up and running, right? Now we have bring up the Kafka cluster. Now what is the next step? Let's see the process, right? Let's see the process is also there. So what we need to do, we need to go into this Kafka container. How we can do this? We can, it's very simple, docker exec the interactive mode and the container id. We are just doing the bash, right? Now we are into the Kafka container, right? Now let's see the let's say the Kafka topics list, Kafka topics, right? So we need to pass the bootstrap server, right? Localhost. Why we need bootstrap server? To connect to the Kafka cluster, right? And let's pass the list, right? So these are the topics we already have. So we already have seen the consumer offsets, right? Now let's see the consumer offsets topic first. Okay, now let's see the consumer offsets topic first. Kafka, or let's create the new topic. We'll do the demo, complete demo again. Let's create the new topic, right? Let's create the new topic. First of all, let's create uh, uh, topic, right? And let's create topic name. We should give the topic name as, let's say, test. Okay, and topic test, let's create it. We have created the topic. Now let's see the list again. Now the test has been created, right? Now let's produce some of the messages onto this topic. I'm just opening the another console, right? Let's clear this, right? So docker ps-a docker exec. In this also we need to go into this container, right? Now we are inside the docker container in both the windows, right? Now let's produce some of the messages. Kafka console, uh, Kafka console, producer, we have already discussed in detail, right? Bootstrap, server, localhost 9092, right? So on which topic we need to produce? We need to produce on topic test, right? Now also let's since we have a single partition, not a problem, we have a single partition. We, for simplicity, we have just created a simple single partition. Let's produce this message, and let's also consume the message Kafka console consumer, right? Bootstrap server localhost 9092, and what is the topic we want to get, and let's give some group name to this. I'll just show you. Let's give the group name is CG, the consumer group, the simple one. Okay, now let's say the simple, or let's give the group as test CG, test consumer group. This is the group. Now let's start the consumer, right? And let's produce some of the message. For example, hello, right? We are seeing the consumer is retrieving the messages. Let's see the hi. The consumer is retrieving the message. Let's say bye, right? Now the consumer has see the consumer is again consuming the messages. The automatically the message are being consumed by the consumer. Why? Because the consumer we have already started. Now let's see one more thing where I want to show you that there is a topic, the same thing. I'll just quickly in here also I need to go into the container. So docker exec, right? So let's see the topic again. Kafka topics, boot strap server localhost 9092 hyphen hyphen list, right? So we can see what is the topic is the consumer groups is the topic. Now let's see the Kafka console consumer.sh, or yes, consumer.sh bootstrap server bootstrap server localhost 9092. Let's read from this topic, the consumer group, consumer offsets topic. Let's read from this topic, consumer offsets. Let's read from this topic. Okay, now let's give some message test. Here the test is being consumed by the consumer, but if you see here what kind of data it is, right? We are not able to see any kind of data. Why? Because Kafka, as I have already mentioned, how Kafka stores the data. Kafka stores the data in the binary format internally. Internally semantics is the binary format. Now how we can see the actual message, that what is the actual message here, what is the actual data in this topic? There's a command for this. We have to provide the formatter. So don't worry, we'll just do that as well. What we can do is we have already prepared the formatter. So this is the Kafka read formatter which we need to give, so that we can have so that we can see the message in the human readable form. Now let's see this. Now let's produce one more message. Let's produce one more message, say for example delay, right? So if you see here what kind of data it is, what kind of data it is, let's copy this, let's copy this, right? Let's copy this. Now I'll just paste it here. Okay, I'll just paste it here, right? I'll just do few more things. I'll just do this, I'll just do this. Now what is this actually? What was this? This was the consumer group, right? I'll show you again. This was the consumer group, right? This was the consumer group. which we have mentioned, right? Now this was the consumer group, and what is this? This is the topic. The test is the topic. Let's see again. What is the topic? The test is the topic. Now what is the zero here? Zero is the partition, right? Now how we have created internally as an engineer, what was our offset key? Let's see here. I'll just move it here. Just give me a minute. Yeah, no, see it. What is the offset key? Offset key is group name, topic, partition. So this is the offset key. Now what is the key here? The group, the topic, and the partition. The similar thing. The dictionary is being used. And what is this? Offset and metadata. This is the kind of offset value. Now what is this here? The offset. Offset is what is the current index of this particular partition, to till how many messages already been retrieved by this consumer in this consumer group. And this last timestamp you can imagine as a commit timestamp. So when was it last committed? So leader epoch and all these things are used for, kind of electing the leader when any consumer goes down. And for this partition has been, so as I already explained, the partition rebalancing, right? As and when consumer in the consumer group joins or leaves, right? So at that point of time, Kafka has to make a decision that to which consumer it should assign the partition, right? So where it will hold this information in the leader epoch, and also it will have some kind of leader uh, ID here, that this is the leader ID and to which this partition has been assigned. So this is how it is actually. This is the simplistic approach. The key value pair is also being used at the Kafka, right? The simple and the easy approach which we also think as an engineer. So nothing is difficult. It's so much easy, right? Now let's see the consumer lag now. So I'll just show the consumer lag, right? Now let's close this. We have already seen this. Now let's let's close this consumer. Now we don't have any consumer, right? So but producer is still running. Let's produce few more message. Hello again, bye again, right? Or say again, right? Or test, right? Or class. So any kind of message we can produce, right? Now how we can see how many messages are being produced by the producer or how many messages are being consumed by the consumer? So there is a command where how we can know this. The command name is very simple, the Kafka consumer groups, right? So this is the simple consumer groups command with which we can know what is actually the status of this consumer group. So consumer groups for connecting the Kafka cluster, this would be the simple. And what we need to pass, we need to pass the group name, right? Test CG, and at the end just do the describe, right? Just do the describe. And I'll just show you here, and I want to show you the complete table. That is why I'm doing all this, right? Now let's see, in this way it would be fine, or the other way could be let's discuss. Yeah, this would be the better view of it, right? Now if you see here the Kafka consumer groups, if we do the describe, right, we can see the current offset and the log and offset. The current offset, let's see, we have already seen the current offset while we were reading the values from the consumer offsets topic. What was the current offset? Offset is 5. So here also, what is the value? The current offset is 5. Now what is the log and of offset? So this log and offset is actually represents how many messages are being already produced by the producer, and what is the current state of this consumer. So current state of this consumer is 5. So what is the lag? is 10 minus 5? It is simple. For is it lag just represents these many messages are still pending to be processed by the consumer. So it simply means that, why this lag is very important. So based on this lag value, you can decide, okay, whether we want to increase the partitions, we need to increase the consumers. So based on application load, if you are facing significant high lag, it means your backend services or your Kafka infrastructure, but your production rate is, or your production rate is too much high, but consuming rate is too low. So you need to scale, or you need to scale things differently. You might need to scale the consumers, you might need to scale the partitions. So based on that, this is so much crucial to know that how your Kafka server is behaving, so that based on this only you need to understand, and you need to design, and you need to take some decisions, crucial decisions in the production, right? So that is why this is so much important to know this. So group, topic, partition, the current offset, long end offset, and the lag, right? So this is, now let's start the consumer, right? Let's start the consumer again. I'll just start it here only. All right, and let's start the consumer. We'll see all the messages are being consumed by the consumer, so which was not earlier processed by this consumer. Now what consumer has consumed, all the messages, all the pending messages has been consumed by the consumer. Now let's see the consumer lag again. Okay, now what is the lag? Lag is 0. Why? Because consumer has consumed all the messages. So in the production, whenever there is a high lag or any kind of these things, so if you scale the consumers, the other consumers can pick up few of the partitions and can process all the messages separately, and your lag would be cleared in a efficient manner and quickly. So it is very much important to know, right? Now we have discussed all these things, the consumer lag, the how the messages are being stored, how the where the offsets come in picture. Now let's discuss the different scenarios, right? Now what could be the scenarios? For example, it could be 3 partitions in the Kafka server, and there could be different consumer groups, right? Consumer group 1, consumer group 2, consumer group 3. For example, let's assume this is an order event topic, but for this topic there could be different consumer groups. Now what could be the different consumer groups? Product service, inventory service, shipping service, and blah blah other services. There could be other services, right? Now, but how Kafka maintains the lag? Maintains the lag by the consumer group, right? It could be possible that this consumer group lag is 10, this consumer group lag is 0, this consumer group lag is 2. So it is, all are operating isolatedly, right? So all are operating isolated. So the lag is interdependent, not interdependent actually. Lag is isolated from the other consumer groups, right? So might be this is product service is very fast, or the, let's assume the inventory service is very fast, you, because you have designed in such a way you have the efficient number of consumers in this consumer group, so your lag is 0, getting 0 each, and in a very quick time of frame, right? But here if you see the consumer in this consumer group CG1, there is only one consumer, right? So it could be possible you can see the high lag, right? But if you see the consumer group 3, here you have only 2 consumers in this consumer group, so there could be a lag 2. So the gist is, the main point is, the lags are not interrelated, it is operating independently based on the consumer group. So this is the main point of this, right? Now what is actually the partitions, consumer groups, consumer lag, these are very important for scaling Kafka, and believe me, you would definitely get one or the other questions in the interview from all of this, right? So that was all I tried to cover, and in the next video we'll discuss more detail on offsets, and also we'll discuss Kafka performance benchmark. So thanks a lot, and see you next video. Please do like, comment, subscribe, watch other videos. I have prepared this series in a very tailored way so that it should be beginner friendly and you all guys would be easy to grasp and understand. So believe me, it would be very much fun, and all the videos are very much practical, and I want each of you to master Kafka. So see you next video. Thanks a lot, and please do watch, like, subscribe and comment. Thanks a lot.